Okay, I've chosen some pretty mean examples over here. So there are your more serious rules of differentiation questions. So that being said, you want to know how to do these. This is, if your teacher's wanting to challenge you, this is definitely an area she could do it in. So just make sure, again, you're working with me. Don't just watch what I'm doing. Work with me, because that's going to be the difference between you understanding it and just understanding me do it. Okay. All right. So we're just going to work through them carefully, and let's see how we go. Find ds over dt. So do you understand the notation? Find the derivative of s, because that's what we're doing it in terms of t. So derivative of f, s in terms of t. What are my problems? What am I spotting as issues right now? I've got a square root, I've got a square root, I've got another square root, which also happens to be in the denominator. So there's like a whole lot of stories that we need to cope with over here. Then, okay, so let's actually start with that. I've got s is equal to, so instead of t, the square root of t to the 5. Do you agree with me? We can write that as 5 to t to the 5 over 2. Then I've got 2. Instead of the square root of t cubed, I'm going to say I've got t to the 3 over 2, all right? And that's over. I've got 3, and then I've got t to the 5 over 2 again, all right? Now, please listen to what I'm telling you over here, all right? This is what a whole lot of people would do. They would look at this and say, oh, awesome, I've got a t to the 5 and I've got a t to the 5 over 2 and I've got another t to the 5 over 2, so they can cancel. Yay, those are gone. No, 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 no. You can't do that, okay? Why can't you do that? Because these terms are being separated by a plus. And as soon as you've got terms separated by a plus or a minus in the top in the numerator, you may not ever cancel over a plus or a minus. So please don't do that, okay? You cannot cancel that. So what can I do? All right. So here's the next point where I'm going to say, listen to what I'm saying to you here. You've got one term in the denominator, okay? Now, if you ever have that, where you've got one term in the denominator, split them. All right, did you hear me? Split them. So what do I mean by that? You've got 3t to the 5 over 2, and I'm going to put it over its own denominator of 3t to the 5 over 2, plus then I had 2t to the 3 over 2, and I'm putting it over its own denominator of 3t to the 5 over 2. So can you see I have split the denominator and I've given each term their own one, okay? That now is going to help you simplify this nicely. Now I can say that cancels with that cancels with that, and we're left with 1 in that first term. Over here, 2 over 3 is not going to simplify, so that's going to have to stay 2 over 3. But if I've got t to the 3 over 2 over t to the 5 over 2, remember your rule of exponents. If you're dividing bases, you subtract your exponents. So essentially, I've got 3 over 2 take away 5 over 2, which is giving me t to the negative 2 over 2. 2 over 2 is 1, so it's t to the negative 1. Look how much simpler that is, okay? Now that it's in that form, let's find the derivative. So the derivative of s in terms of t is as follows. Constant term, goodbye. Negative 1 multiplies by your 2, so therefore it's negative 2 over 3t, and then we subtract 1 from the exponent, so we're getting negative 2. Obviously, last step, I don't want you to leave your exponent as negative, so we bring it down to the denominator and we make it positive. Okay, so I'm going to repeat myself over here. If you're sitting with one term in the denominator, split the terms and give them each their own denominator, and you won't believe how much easier that makes your life. Okay, right, so then we're sitting with an example like this. Yikes. Okay, what have we got here? A whole lot of hard work. I've got a big square root, so obviously, well, a big cube root actually, so I'm going to obviously have to deal with that at some point. But this is what this whole story underneath the cube root is really what we're going to have to deal with first and foremost, because there's a whole lot of issues going on there. So I think for now, what I'm going to do is, okay, well, let's just work with just this. So I've got x to the negative 1 plus 2 over my x cubed plus 2x to the 4. I need to simplify this because otherwise I've got problems. Okay, x to the negative 1. Again, you've got this very frustrating plus separating your terms, which means that you are so limited. You cannot bring negative 1 down, the x to the negative 1 down to the denominator. You can't do that, okay? This is the only thing you can do with this term over here, is you can write it as 1 over x, but you have to keep it as part of the numerator. And then you've got your x to the 3 plus 2 x to the 4, okay? So can you see what I did? I created its own fraction, but I kept the whole term up in the numerator. Now to balance this, I'm going to put it over 1, and I'm going to find a common denominator. So the LCD is x, that's going to stay a 1, and that's going to have to become 2x. But it's all still over x cubed plus 2x to the 4. Okay. Now let's look at this. We have got this line over here, which means divide, all right? And instead of having a fraction over a fraction, let's rather rewrite it with divide. So I'm going to write this as 1 plus 2x over x, all right? And remember, if this was a fraction, this would be over 1. So I'm going to tip and times it and write it as 1 over x to the 3 plus 2x to the 4, okay? We need to somehow try and cancel these things, and at this point, highest common factor is almost always your lifeline, okay? You've got a common factor in those two terms over there. So 1 plus 2x over x, there's nothing more I can do to simplify all of that. But down below here, I can take out an x to the 3, which is going to leave me with 1 plus 2x. And by doing that, do we notice that that and that are exactly the same? So they will cancel. All right, and then magically things are looking a whole lot more simple. I've got 1 over x to the 4. That's what we're sitting with, okay? Now bear in mind that's what I've just simplified underneath the cube root sign. So let's just get ourselves back into the sum here. So d of x is looking for the cube root of 1 over x to the 4, okay? So now we need to get rid of the cube root story. All right, x to the 4, if I've got 1 over x to the 4, basically to get rid of the cube root, we're going to raise it to the power of 1/3, okay? So if I've got, if I have got 1 to the power of anything, 1 to the power of anything is always just 1. But x to the 4, if I times 4 by 1 over 3, I'm going to get x to the 4 over 3. Okay? It's in the denominator. It's in the denominator. We don't want it there. So it's going to have to come up into the numerator, and it's going to be negative 4 over 3. And finally, I'm ready to apply the rules of differentiation, which is going to give me negative 4 over 3 x to the, if I subtract 1, that's the same as 3 over 3, so it's going to be giving me negative 7 over 3, which finally is negative 4 over 3. That's coming back down to the bottom because we want it to be positive. And the last thing we can do is write it back in third form, which means it's the cube root of x to the 7. Okay. Mind bender, that one was hectic, and I really suggest go and do that one again. Okay, but yeah, as I say, if your teacher's wanting to really give you a nasty, then that's probably along the lines of what you can expect. Okay, just one step at a time. That's your rule. You know, those kind of questions, those massive examples, just one step at a time. Last question quickly over here. This one is nice because it just plays around with notation a little bit. They've given me the root of x, which is equal to y to the power of 1/3. And they've also given me that y is equal to z to the power of negative 3. Now the first question says determine dy over dx. So I'm looking for the derivative of y in terms of x. Now that's going to have to come from this one over here because you've got your y and you've got your x. But let's just look at it for a second. They gave me the root of x was equal to y to the power of 1/3. Okay, now in order to find the derivative of y in terms of x, you need to get y entirely on its own. Okay, so that means that this 1/3 has got to go. I can't have that third there because then y is not on its own. Instead of x, I'm going to write it as x to the half and y to the third. How do I get rid of a third, an exponent of a third? You tip and times it. Okay, so you times it by 3 over 1. But what you do to one side of an equation must be done to the other side. So these essentially all cancel each other out, and I'm sitting with x to the 3 over 2 equals y. Now I'm ready to find my derivative of y in terms of x by saying 3 over 2 x to the, if I subtract 1 from that, I'm going to land up with 1 over 2. All right, so that's the derivative of y in terms of x. Now they're looking for the derivative of x in terms of z. So I need to have x on its own and then z on the other side. Now let's look here. The equations they gave me, I had an x and a y together, and I had a y and a z together. There's no equations where there's an x and a z together. All right, so now that's a problem. All right, they've given me that y is equal to z to the negative 3. Y equals z to the negative 3. That's what they gave you. Okay, we worked out earlier that y is also equal to x to the power of 3 over 2. So here's where you can substitute. So instead of y, I'm going to write x to the power of 3 over 2 equals z to the negative 3. Okay, now I've created this equation where I've got a z and an x. Okay, so you just got to be clever with these things. We need to find the derivative of x in terms of z, which means that I need to get x entirely on its own. And the way we're going to get x entirely on its own is I need to get rid of that exponent of 3 over 2. How do I do it? Tip it and times it. So 2 over 3. But what happens to the one side always happens to the other. So this all cancels out, leaving us with just x. And this cancel is going to land up with negative 2. Okay, so the derivative of x in terms of z is going to land up equaling negative 2z to the negative 3, which obviously becomes negative 2 over z to the positive 3. Okay. Right, so those are some pretty tricky examples, and I'd really like you to go and review those again because I think there's a lot of learning to be had in those couple of examples, and then go and practice them. Okay, these are marks that are not difficult to get in your exams, but you've got to practice it. It's got to be something that starts coming naturally to you. Okay, so off you go. Good luck with it. Hope they all work out nicely, and I will see you next time.